Let's go back, right? So we're taking a look at kinematics today, which takes a look at a few quantities, right? Displacement, velocity, acceleration, right? So it has to do with these three quantities, right? Displacement S, velocity, acceleration. Always remember that displacement is a straight line distance from where you start to where you finish, right? That is called a displacement. Straight line distance from where you start to when you finish. So if you travel, do all of this fancy thing here, it don't matter, right? The displacement is from where you start to where you finish, that distance. One thing I want to point out here is this, right? If you were on a road, let's say here's O, and let's say here's A. And here to here is 5 meters, right? If you travel from O and go to A, displacement is 5 meters, correct? Are you okay with that? Because you start at O and you finish at A, right? But suppose you went back to B. Let's say B is 1 meter away, right, from A. So let's say you went from O, then you went to A, and then you finish at B. Your displacement will be the straight line distance from where you start to where you finish, right? So your displacement will be 4 meters. That's okay there? So your displacement is a straight line distance from where you start to where you finish. It's also a vector quantity. So any displacement you measure on the right side, positive, right? And if you were to go to the left side, your displacement becomes negative, right? So you have to remember that in case you end up with a negative displacement value, that's what it means, right? Next is velocity. Velocity is your change in displacement over time, right? That's why to go from displacement to velocity, we differentiate. Okay, we differentiate displacement to go to velocity, right? Also remember, velocity is a vector quantity. So if one direction positive, then the next has to be negative. Okay, so if you end up with a negative velocity, it simply means that you change direction. What's acceleration? Acceleration is the change in velocity. Acceleration is the change in velocity over time, right? That's the acceleration. SI unit, ms minus 2. We need to remember a few things. If a body has an increase in velocity, you have a positive acceleration. If you have a decrease in velocity, you have a negative acceleration, which we call deceleration. Okay, so you need to remember those things, right? If you see a positive acceleration, it means that the body has an increase in velocity. If the velocity is decreasing, it means that we have a deceleration. Right? It's a deceleration. Okay? And that's the way we move down the ladder. To go up the ladder, we do the reverse. We integrate acceleration to get velocity. And here, we integrate velocity to get displacement. Okay, copy it down. And we're going to attempt some questions on this, right? This is our last topic in applications, right? So next week, I give you a little break next week, and then the week after, crash courses will start, right? AdMass is the last week, I think. It's a bad days, but that's what we have. Right? So you basically have to remember those things, but there are little tricky parts in between where you have to remember that displacement is a vector and displacement, velocity, and acceleration, that they're all vector quantities. Ready? So let's try a few, right? Taking this off, right? Right, so just remember the ladder and hopefully you remember how to differentiate, right? I think we did a few of these on Monday. We did a few on Monday, but I'll do back two of the easy ones and then right, that's with 2013. Take a little read. We'll talk it through together. Take a little read. That's 2013, right? Right, so let's go, right? So a particle travels in a straight line in such a way that its velocity is given by that. Calculate the values of t when it's instantaneously at rest. What does instantaneously at rest mean again? It means that the object has stopped, so its velocity is 0. Right? So this thing not working. Right, let's come back here, right? So if you look here, they gave you an equation for velocity, right? And they want the times when it's at rest. So basically they want when v is 0. So you have to take 3t squared minus 18t plus 50 plus 15 equal to 0 and solve it. And you will get what? T is what? T is 1 second and t is 5 seconds. That's okay? Oh, we did this one already, huh? Yeah, it's one looking familiar. The distance traveled by the particle between 1 second and 3 seconds. So you want the distance. How you get distance again? Integrate, right? So you integrate between 3 and 1. And you have to integrate the velocity, right? So you're going to integrate the velocity between 3 and 1. So you're integrating 3t squared minus 18t plus 15 dt. Okay, integrate it and then plug in 3 and 1. Tell me what you got. Right, integrate it, tell me what you get. Plug in 3, plug in 1. Right, so when you integrate, you should have what? When you integrate between 3 and 1, you should have t cubed minus 9t squared plus 15t. Look at that. When you integrate, then plug in 3 and 1, right? So that's 3 cubed minus 9 by 3 squared plus 15 by 3, and then you're minusing off 1 cube, right? 3t cubed and 3 of sorry. So the 3 will cancel. Right? Minus 1 minus 9 plus 15. How much? Minus 16. Right? So the distance traveled as far as we see in there is 16 meters. What you all got for the first one? When it was 3 when it's 3 seconds, was the distance covered for this part here? Minus 9. And the next part is what? 7 or something? 7. Okay, right? So the distance covered, you can ignore the sign. The difference distance covered is 16 meters. So basically, here's what happened, right? You have to have an idea what's going on. Here's O. Here's where the starting point is. So at 1 second, the displacement was here, 9 meters away. And then at the third second, it was on the positive side. So this total distance traveled here is 16 meters. Right? This is minus 9 side, right? Okay, just to get a little idea what's going on. He was at minus 9, then he went across 37 meters. Right. What does dVdt give you? What does dVdt give you? Chabaki chart. dVdt gives you acceleration. Right? What's the differential of V? Get it mentally, Shana? What's the differential of V? No, you differentiate in V. First equation. Right? 60 minus 18. Nice. That's the acceleration, right? When T is 2, tell me what you got. When T is 2, tell me what you got. What you get? Minus 6. Right? Minus 6 meters per second squared. And when T is 3, what you got? 0. Nice. So can you explain what's happening at A and B? What's happening at A and B? When it's 2 seconds since the acceleration negative, what happening? Look back at the small note. It is decelerated, nice. And then what happened at B? What happened at B? The acceleration is 0. So it means that it either came to rest or it now at constant velocity, right? So either one could happen. So in part 4A, we could say that it decelerated because the acceleration negative. Yeah, Timia, you okay with that? And then in the last one, because the acceleration is 0, we could say it either at rest, it came to rest, or at constant velocity. Okay? Right? And it shouldn't be at rest. How do you know that? Look back here. It only at rest when T is 1 and T is 5. So we could ignore at rest. Right? So the answer for B is that it's at constant velocity. It's moving with a constant velocity when T is 3. All right, let's go again. Right, so you have to remember those interpretations, right? Negative acceleration means a deceleration. Right? And acceleration is 0, means that's constant velocity. When the acceleration is 0, it has constant velocity. All right, let's go again. Try this next one here. This is 2015. 5 marks each, right? Let's see what happens. This time they give you acceleration, right? So how do you get velocity, Ocean? You have acceleration. So you're going back up to velocity. Integrate, right? So you integrate. So you're going from acceleration to velocity, so you're integrating. Then plug in t as 4. And then part 2, similar kind of thing, right? But we have a problem. When we integrate Sarah, what is get? What is normally get when you integrate? Plus c. So you have to use the information given to get rid of the plus c. Okay? And they gave you all the information here. Any question? When t is 0, v is 4. Right? When t is 2, a is 6. Go ahead. Let's see if we can get 10 marks there. Hopefully you can integrate good, right? You can integrate it, Elena? The question is again, you gotta go, man. Try that F, man. Chocolate. Done. Right, so I can do the first part. So the first part is where we have to integrate. First part, we have to integrate the velocity. That'll give us the acceleration, right? Sorry, integrate the acceleration. So we're going to give us velocity. So we're going to integrate 3t minus 1 with respect to t. And we will end up with 3t squared on 2 minus t plus c. Problem is the plus c, but the question told us that v is 4 when t is 2. So 4 is equal to 3 by 2 squared over 2 minus 2 plus c. Right? So I got c to be what? That'll be 2, 2 will cancel there. That'll be 6. That'll be 4. C is 0. Yeah? C is 0. So v is equal to 3 on 2t squared minus t. And they would like the velocity when t is 4. So that'll be 3 on 2 by 4 squared minus 4. Right? 4 squared was 16. 2 into 16, 8. That's 24 minus 4 is 20. Yeah? 20 meters per second. So part 1 is 20 meters per second, right? That's the velocity. That's all we have to do, right? No change in direction or nothing. Are you okay with that? Yeah. And the last one is what? You'll finish it? Yeah? No? Hurry up. I just pass and check. Do a little video on you there. Oh, you won't see yourself. Just a quick reel where to correct it. Right? Huh? Yeah, come on. I just go from displacement. Yeah. Take it now. From here to here, where is it? I will do that. What is it? Yeah, what's it? I found it. Yeah, do it up, I think do it. And R1 right? R1 to the power and divided by the power. Well done. Finish. Right, so let's take time here. Right. So I want to power. Right, and take it in, right, right. So let's check it out and see. So they want us to get displacement. That's the integral of displacement is the integral of velocity with respect to time. So we integrate in the equation we had below, which is 3 on 2 t squared minus t. Right? When you integrate that, you'll get 3 on 2 t cubed on 3 minus t squared over 2 plus c. So s is equal to 3t cubed, 2 by 3 is 6, minus t squared on 2 plus c. Right? We need to get c, so we go back up to the information given, and they told us s is 6, t is 2. So 6 is equal to 3 on 6 by 2 cubed minus 2 squared on 2 plus c. So c was how much? C was 4. Anybody else get 4? C is 4. Anybody got C? Anybody got 4 online? Half of 8 is 4. All right, so C is 4, right? So S is equal to 3 on 6 t cubed minus t squared on 2 plus C. So that's plus 4. And the question wants when t is 3. So the last part is S is equal to 1/2 by 3 cubed minus 1/2 by 3 squared plus 4. How much is that? 9 on 2 minus 9 on 2. Cancel off. Oh, sorry, 27 on 2 minus 9 on 2 plus 4. Right? That's what 18 on 2, which is 9, 13. So the answer is 13 meters. Anybody got that online? Oh, Amanda got that. Anybody else? Jaden, nice. Dimitri didn't send anything. Kalia, don't send anything there. To be sure to forget, man. Right? So the value is 13 meters, right? Dibbly, 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 bop, bop. Blue pen? What color it was?
Black pen.
To be sure, I mean, to me, I'd take it. I think to me, I'd take it. Paul's taking. Paul, that's what you'll be doing? Paul's the follower went on there. Huh? You don't know how to find? C, you have to use the information here. They told you when S is 6, T is 2. So you have to plug in that. Somewhere in the question, just give you the information. And when you plug in the T and the S, you can find C. That's okay? Sure. The next one you come board, and I recording it. Right, let's go again. Any questions online? Dibbly, 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 bop, bop. Dimitri, you're able to send an answer tomorrow, please. Just one. Dibbly, 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 bop, bop. Bop, 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 bop. Yeah, let's go again. Plenty, this is integration, right? Actually, in your exam, it's only integration you will get, no differentiation in kinematics, right? They'll actually have the time graph part. Next one here. Try this out. Anybody else come? Yeah. Go ahead now. Go ahead. Try it off from there. That is 20. Right? Remember to work in radians, right? Well, I'll see in pi, so you should know that. Right, let me forget any answers here. We could have said pi and you're hungry, we? Let me for a little pie boy ocean. Hungry. I take them churn ramen from last night. So I have 2 ramen to bust up later. If I can't make it. Right, so they give you, they want you to find acceleration. Acceleration is the integral of velocity, correct? Yeah. So when we integrate the velocity, we integrate in cos t. When we integrate cos t, wait. I write it back to front. I put the front in the back and the back in the front. So here's v and here's a, right? What's the integral of cos t again? Sine t, right? So sine t implies that sine t plus c, sorry, that we still need to get c. Question told us it started from rest. So when t is 0, v is 0. So when you plug in that, you'll also get c is 0. So the equation is sine t, right? And you're good to go. You're good to go. That's okay? Right. Let's see if Sarah can help us out here. How we getting displacement, Sarah, if we have velocity? So she got some blood pressure up here. Yes, Sarah. How we going? How we getting displacement from velocity? Are we saying no? I'm moving. I'm not moving from here until the terminal. How are you going from the velocity to the displacement? You're integrating or differentiating? I waiting too. I have hold there. And my girl is asleep too. Look at it. Look at your middle graph. How you move from velocity to displacement. Ready? You're going up, right? Velocity to displacement. So what you'll do? Sarah? You look at your graph. You see velocity, you see displacement. And the arrow pointing up, right? Well, what do you do to go up from the velocity to the displacement? You have to do show me a sign. If it's integration, show me 1. If it's differentiation, show me 2. Sarah? Which one? Huh? So look back here. Look, watch back here, right? If you have displacement, velocity, and acceleration, right? To go from displacement to velocity is differentiate. Okay? That's okay? If you differentiate displacement, you'll go to velocity. If you differentiate velocity, you'll go to acceleration. Right? To go back up here, watch here. You're going to integrate acceleration to get velocity. Right? And to go from velocity to displacement, you're going to integrate velocity. Follow how the graph works, chart works. You're going up, you integrate, you go down, you differentiate. That's okay? Sarah? Yeah? So how do you go from velocity to displacement? What you will do? Sarah? I don't hear you. You see me? Ishana can't hear you, so I definitely can't hear you. How are you moving up the chart from velocity to displacement? Sure. All right. Integrate. Yes. Right. So to get the displacement, we have to integrate velocity. But it told us what? Between pi and 2 pi. So between pi and 2 pi, we have to integrate. Okay. So we're going to integrate sine t between 2 pi and pi. The integral of sine is minus cos, right, between 2 pi and pi. So what we'll get there, right? You substitute cos 2 pi minus cos pi, right? So that is what? 1 minus 1, which is 2. So the answer is minus 2. Minus 2 meters. Yeah. Remember, you must work in radians, right? Minus 2 meters. Copy down, plug in the values, copy it down. Let's go again. Last one. All right. Let's go further down the road here. Let's do one I never did before, right? Last one. This is 2022. Right? This is what will look like in your exam, right? Oh no. What do we do? Oliver still totally head there. I don't know what to do. I really can't help Oliver. I don't know what to do. So Oliver can't do that? Oliver want me to do that? How do we rotate? How? Save it and then rotate it. Squibbly, quibbly, quibbly, bop, bop. Oh no. Yeah, I see. I seize it. It has been seized. Copy it down. Right on the info. I want to pass to somebody book and check what you have, right? Huh? We just did? For real? What's going on? Yeah, but I just that's 2022. I remember that I repeat. Yeah, it's a repeat. You see? 2022. Just waste paper. You never know. Let's check out 2021 then. This lady doesn't write up anything or not. This one free of all writing. So 2022 was the same thing from before, right? So that was a repeat. Let's try 2021. Oh, how I wish I were a child. I can see anything at all. All right, good. Let's try this one here and we're done. Real basic stuff. Take your time. They give you acceleration, they want velocity and displacement. Easy maths. I am watching. I am watching. Right? So your velocity, integral of your acceleration, right? So you're going to integrate t squared dot dt. The integral of t squared is t cubed on 3 plus C. Okay, so you have to remember that, right? So the integral is t cubed all over 3 plus C. We need to get C, so we know that it starts at rest. So when t is 0, v is 0. So when you plug in that, you'll obviously get C is 0. So your equation is v is equal to t cubed on 3. Last part, 2. They want to get the displacement. That's the integral of your velocity. And they said between 0 and 2. Okay, so we're going to integrate between 0 and 2 velocity, which is 1/3 t cubed. Right? So you have between 2 and 0. You can put the 1/3 outside, so you don't have to worry about it. You'll get t to the 4 and 4. Right? You have a quarter there, so a quarter by a third is 1/12. And then you plug in 2 to the 4 minus 2 to the 0. Right? I just pull out the 4 one time, right? So I don't want to work with it. So you'll get 2 to the 4, that's 16. So you'll get 16 on 12. Right? 16 on 12, which is 4 over 3 meters. Correct? And you're good to go. All right, so that's it. That's it for your applications of differentiation and integration. So we're done with that. I'll give you a break next week with from AdMaths, and then we go back in crash course again. Crash course, you will see plenty of questions I did already, right? What I'm also doing, I will put up the solutions for all the years. Well, I know it there already, but right, and pass of all. All right, well, I will still do some videos on all the years so you can look back at that. Okay, I'll do some videos on all the solutions. Right, so you will have the written and you have the videos. Okay, so nice. Right, so no AdMaths next week Saturday, right? Monday I'm doing a full pass paper, and that's it for AdMaths for the term. All right, next time AdMaths will be crash course. Okay, so nice.